In lesson 4.3, we are graphing quadratic functions and identifying certain properties of those functions. So let's get into an example. We worked on problems 11 through 18 in class, and it's just a little matching exercise where you're given some quadratic functions and you have to determine which graph matches the appropriate function. And so here are some things to consider. When you're looking at standard form, which is the form that all of these functions are given to us in, standard form looks like this in general. So from standard form, we can gather some important information just by looking. For example, when you're looking at standard form, this number on the end identified as C, you can think of C standing for constant. It's just a number without a variable. Well, that number represents the y-intercept. Every parabola has a line that cuts right through it. It divides the parabola up into two equal parts. I'll just give you a little simple illustration here. This dotted line that divides my parabola up into two equal halves is called the AOS. And the way we find the AOS is by doing this little formula, the opposite of b over 2 times a. Well, as you can see, a is the number in front of x squared, b is the number in front of x. Okay, so that's important when we're trying to determine matching, for example, matching functions with graphs, and I'll show you how that works in just a minute. If we want to know this vertex point, the point that this dotted line cuts through, then all we have to do is take our AOS number and plug it back into the function for x. Okay, and that's what this is saying. The vertex, the ordered pair of the vertex will be the AOS number and then the output from the AOS number. And then something else you can always be on the lookout for. If the number in front of x squared is a negative, then that means we're going to have a parabola that opens down. Okay, so with that said, we'll take a look at, if you've got your book open to page 297, let's just take a look at some of these functions. So we'll start with number 11. I notice that on number 11, it's got a y-intercept of -1. Okay, so let's take a quick look and narrow down our choices, A through H. Let's find y-intercept -1. Well, letter E has a y-intercept -1, and so does letter C. Okay, so our two choices so far, we've narrowed it down. It's got to be either letter C or letter E for number 11. Well, since the number in front of x squared is positive, it can't be letter E because letter E opens down. So the answer for number 11 has to be letter C. Okay, which means then if we move over to number 12, that's going to be the answer for number 12. It's letter E because that has y-intercept -1. And then if you notice, the number in front of x squared is -1, which tells us the parabola has to open downward. So the answer for number 12 is letter E. Okay, and we'll just keep walking through these. Letter F, I notice, has a y-intercept of +1. Just look at the constant on the end, or this number 13, has a y-intercept of +1. So that means we're dealing with either letter A, graph letter A, or graph letter F. Well, to see which one it is, we need to determine the AOS using the opposite of B over 2 times A. And if you do that little calculation, the opposite of -2 over 2 times 1, you're going to get an AOS of +1. X equals +1. Well, letter A has an AOS of x equals -1, so that can't be our choice. So the choice for number 13 has to be letter F. And then if you move over to number 14, that's going to be the choice for letter A because the AOS for number 14 will have to be x equals -1. Okay, so I've run through those first four, and that just leaves four more for you to do, 15 through 18. See if you can match up the letter of the graph with the function that's provided there on 15 through 18. Okay, now when we get down to numbers, for you, it's the evens 20 through 30. You're supposed to graph, and the directions say to graph by using transformations. And in some cases, that's going to be easy to do, but the bottom line is, as long as you come up with the graph, I'm okay with whatever method you decide. What we have here is another kind of form for a quadratic. It's called vertex form. Notice that it's quite a bit different from the standard form that we looked at over here. So two forms of quadratic functions that you really need to be familiar with. The standard form, ax squared plus bx plus c, and then this is called vertex form, and I'll just write this up in general. In general, vertex form will always look like this. It's great if we're already given a quadratic in vertex form. It's a really nice form to graph out of because we can literally see what the vertex is. That's where it gets its name. The vertex will be whatever these numbers are in place of h and k. Well, to look at my blue vertex form using just variables and compare it to the given red function, h must be -2 because subtracting -2 would make +2. And k is going to be whatever is outside of the parentheses, and so in this case it's also -2. Okay, so my vertex, my starting point, will be -2, -2. And now to get the rest of the graph, I'm just going to do an input. My AOS is obviously going to be the line that cuts right through the vertex, and this is where I have symmetry. I have this line that breaks or cuts my parabola up into two equal halves. So from here, just come up with an input. And if you're wondering, well, what do I use as an input? Just choose something really close to the AOS, all right, like -1. That's as close as we can get. We don't already have a point on x equals -1. So let's see what comes out if I input -1 for x. -1 plus 2 is 1. 1 squared is still 1, and 1 minus 2 is -1. So -1, -1 is on the graph, and because of symmetry, I know that this point, -3, -1, is also on the graph. All right, so I'm just going to do a rough sketch. Parabola, you can just use 3 points, and looks something like this. Crooked. Yeah, it's going to be good. Looks more like a V, but okay, so that will be your process that you will follow when you do 20 through 30 even when you're given vertex form. Well, let's do one where we're not given vertex form. We're given standard form. Well, there's two ways of going about it. I'm okay if you just go ahead and find the AOS. Remember, you can do opposite of b over 2a, and that will give you the AOS. And the opposite of, in this case, would be the opposite of -4 over 2 times 2. So inside the parentheses, it's -4 divided by 4, which is -1, but the opposite of -1 is +1. All right, so that's my AOS, and on the AOS is the vertex. The vertex will be found by taking this AOS number and putting it back into the function for x. Okay, 2 minus 4 is -2, plus 1 is -1. So my vertex is the point 1, which was the AOS, and -1, which is the output from the AOS. All right, and an easy point to plot when we're looking at standard form is the y-intercept. this constant. Whatever the constant is, if there is no number showing, then it's understood to be 0. Well, I know that this graph has to cross the y-axis at positive 1, and so because of symmetry, I can match that up over here on the other side. And those 3 points will be sufficient. I'm just going to connect them, and this is going to be my parabola. And that is my answer for number 25. So I've given you 2 examples of what to do in 20 to 30 even. Depending on whether you're given vertex form, there's an approach. You don't have to calculate the vertex, you can see it. If you're given standard form, then you can just calculate the vertex using this formula and then plug that number in. And the y-intercept is an easy point to graph. So depending on the function that you're given, it will determine the approach that you take on coming up with the vertex and the other characteristics, y-intercept and so forth. Okay, we're going to skip over this and let's do let's go ahead and do number 31, but I'm not going to require that you change the vertex form. So you can just kind of ignore this part. We're going to find the AOS by doing our regular formula that we learned earlier, the opposite of B over 2A. So the AOS using this formula is the opposite of B, which is 2, over 2 times 1, and 2 over 2 is 1. Opposite of 1 is negative 1, so the AOS is the line x equals, let's write it down here, x equals negative 1. The vertex, you find the vertex by putting that number back into the function for x. And 1 minus 2 is negative 1. So the vertex in this case is negative 1, negative 1. Okay? Some other things, if you notice the instructions on this set of problems, we're supposed to sketch the graph. We're supposed to determine whether it opens up or down, and we talked about this earlier. It's going to open up because the number in front of x squared is positive, so you can state that as part of your answer. The y-intercept, remember, is, since this is standard form, it's the constant on the end, and since there is no number visible, it's 0. The x-intercepts we'll just determine by, we'll look at our graph when we're done. So let's just go ahead and plot what we know so far. We know that the vertex is negative 1, negative 1. Okay, negative 1, negative 1. We know that the y-intercept is 0. We know that there's symmetry around this line x equals negative 1. And that's important because it helps us generate other points without having to do any calculation. I'm just going to match this point up, this 0, 0, over here, same distance away from the AOS, just on the other side. And there's a sketch of my parabola. And now with the graph, I can see pretty easily what the x-intercepts are. The x-intercepts are 0 and negative 2. All right, and let's see, there's some more information we're supposed to determine from this graph. The domain of all parabolas is going to be the set of all real numbers. And we've been reviewing interval notation, so the way to show all real numbers using interval notation will be from negative infinity from the left to positive infinity going to the right. The range, however, will change depending on the parabola. So remember, range deals with what y-coordinates are involved in this graph, the set of y-coordinates that would be involved. Well, the y-coordinates begin with negative 1 and they continue to go up from there because that's where this graph is headed. So we want all the numbers greater than or equal to negative 1 as part of our range. So you can do that using what we call inequality notation, all y such that y is greater than or equal to negative 1. Using interval notation, it would look like this. We do want to include -1, so we'll use a bracket, and from there the numbers are going to positive infinity and enclose with the parentheses. Okay, so how do we know where it's increasing or decreasing? Well, just think traveling from left to right. Always think in terms of moving left to right. Decreasing means that as I move from left to right, I'm walking downhill. Okay, so I'm just going to shade in red the part of this parabola where it's decreasing. It's decreasing as I move from left to right on this side of the AOS. And the way I show that, decreasing, and we always use the x coordinates to represent increasing or decreasing. So it's decreasing using interval notation from negative infinity as I come from the left to right. I'm coming from negative infinity and I stop at x equals -1. So the interval notation would be from negative infinity to -1. Now I'm not actually increasing, I'm sorry, let me go with decreasing first. This one's upside down. I'm not actually decreasing at -1. -1 is considered a turning point. So I'm going to come down to -1 and then change direction. So notice how I did not put a bracket for -1. It's not actually decreasing there. It starts to increase, however, from -1. If you notice, increasing means it's going up as we move from left to right. Just think walking uphill from -1 to positive infinity on the x. Okay, and so that's how you'll always use the x coordinates to determine increasing and decreasing. Okay, and this is our last example, so let's just run through this real fast. I know that it's got to open down because the number in front of x squared is negative. To find the vertex, I really need the AOS, so I think I'll find the AOS first. Opposite of b over 2a, the opposite of 2 over 2 times -2. All right, in the parentheses is 2 over -4, that's -1/2, but this makes it positive 1/2. So the AOS will be the line x equals positive 1/2, and the vertex will be 1/2 something, and the way I find the y coordinate is I just put the AOS number back into the function. So we'll do that right here. Okay, you always square before you multiply, so 1/4 times -2 is -2/4, which is -1/2, plus 1 minus 3. Okay, so -1/2 plus 1 is positive 1/2, and 1/2 minus 3 is -2.5. So we found our AOS and we found our vertex, so let's gather some more information and then we'll start graphing. We need to know the y-intercept, and that's always the constant on the end of standard form. So the y-intercept is -3. And the x-intercept's probably easier to go ahead and get the graph, and then we can tell what the x-intercepts are. So let's go ahead and plot everything we know so far. We know there's a y-intercept of -3. Let's see what else we know. The vertex is 1/2 -2.5. 1/2 -2.5. And because of symmetry, you don't have to draw this symmetry line, but you should be aware of where it is. Symmetry means I've got another point right here on the other side of the AOS. All right, so I'm just going to use those 3 points and do a little rough sketch of my parabola opening down. The y-intercept we've already identified. Notice this never crosses the x-axis, so I'm going to say none for the x-intercepts. And I think we got everything else except for where it's increasing or decreasing and domain and range. All right, so domain, again, for parabolas, it will always be the same, all real numbers. The The range depends on the y coordinates that are being utilized, okay, and we came down to -2.5. All right, so it looks like the range starts at -2.5, and those numbers continue to get smaller forever. Okay, so remember, when you're using interval notation, you always go smaller on the left and then bigger on the right. If you're using inequality notation, you would say all of the numbers y such that y is less than or equal to -2.5. Okay, now let's take increasing, decreasing. From left to right, as I come in from the left, I'm increasing, coming in this way until I get to x is 1/2. So from -infinity to positive 1/2, I'm increasing. It's all about the x coordinates. And I'm decreasing on the other side of the AOS. So from 1/2 to positive infinity, I am decreasing. Okay, and I think we've got it all. I think you don't have to worry about those. And so your assignment will be on 297. You're doing the rest of the matching problems, 11 through 18, and then it's 20 to 46 even from there. So just pay attention to how the directions change. When you leave number 30 and you come to number 32, you've got quite a bit more information that you need to record. All right, so I hope that helps, and let me know if you have any questions.